Hi, my name is Farhad Tafezi from Switzerland, and I will talk to you about Pack Cxl for infectious keratitis. Most of you will know the indication of cross-linking for keratoconus, a rare disease. Now what makes us very excited is this new indication of cross-linking for infections, and especially bacterial and fungal keratitis, one of the major causes of global blindness. So it is a chance for us to move cross-linking from a niche to a mass problem, which is blindness due to corneal ulcers. Concept of photoactivating a chromophore like riboflavin to reduce the antimicrobial load of liquids or surfaces is not new in medicine. It has been applied in transfusion medicine, for example, in platelet concentrates for almost 20 years now. If you want to disinfect a liquid or reduce its antimicrobial load, you use the combination of UV light and a chromophore like riboflavin. If you want to disinfect a big swimming pool, an Olympic swimming pool, what do you use? UV light and riboflavin. So the concept of killing microorganisms with this combination has been known. How does it work on the cornea? We showed the proof of principle back in 2008 in a first case series of 5 patients. And basically there are three hypotheses for potential mechanisms. The first one is intercalation. This means irreversible binding of the chromophore of riboflavin to the DNA of the pathogen. So this is a suppression of replication. The second mechanism might be the sheer number of reactive oxygen species, so oxidative stress that disrupts the cell membrane. And the third one is that cross-linking per se changes the tertiary structure of the collagen fibers, and so collagenases that are upregulated during a corneal ulcer, let's say, have a harder time to dock to the cleavage sites. So the combination of these 3 potential mechanisms makes cross-linking a powerful and unspecific weapon against Pseudomonas aeruginosa, against Staph aureus, even methicillin resistant, etc. In 2008, the concept was given, and then we went into extensive in vitro studies and showed that we can kill almost 99% of bacteria, but also certain fungi. So the main causes for global infectious keratitis in vitro. This was all done using the basic parameters the Dresden Protocol originally established in keratoconus treatments, so a relatively slow procedure. Now, if we look at the unmet needs on a global perspective, we need this method, if we want to apply it, we need it to be fast, inexpensive, and very efficient. So this is what we've been working on in my research group in Switzerland in the past years. Right now, we are able to kill 99.9% of MRSA within 150 seconds using a new chromophore that is not riboflavin anymore and that I cannot disclose right now. We were able to miniaturize the technology to make it this big and mountable on a slit lamp, because we need to move out of the operating theater. And we are able to address both fungi and bacteria. So putting together all these new specifications, our dream would be that an early ulcer, as it's been detected, let's say in Bangladesh, the patient comes to the eye doctor, and the eye doctor would perform a 150-second treatment at the slit lamp to reduce the bacterial load by 99.9%. And this is where we are thriving to go. So hopefully Cxl, or Pack Cxl, how we call it now, Pack stands for photoactivated chromophore for infectious keratitis. Cxl will bring cross-linking to new heights and out of the niche of keratoconus treatment. My financial disclosure is I'm named co-inventor on a new UV light source.